Okay, hello and welcome to the day one lecture. So we went over this in class today, but just in case we needed to get like a quick little refresh, that's why I put these videos up to help us out. So today we're talking about adding, subtracting, multiplying, and dividing integers. And we want to recall that integers are positive and negative numbers with no decimal part. Okay, and I mentioned this in class as being, mainly that they didn't have a fraction, and that's the same idea, right? They don't have anything attached to the end of the numbers. They're just, they're the whole numbers. You might think of them that way. Okay, the whole numbers that are both positive and negative. So when we look at adding and subtracting, I kind of go with a couple different ideas. First of all, using a number line, I like that method. If I think about 5 here, so I'm just going to start with the first number I'm given, and then I'm going to add 8. So not to scale at all. 1, 2, 3, 4, 5, 6, 7, 8. So I'm moving this way. Since I'm adding, I'm moving this way for plus 8. And this is a great representation, a great method to understand addition and subtraction. So all I have to do then is just count from 5 to my last line. So I'm thinking 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's a good idea on how to add and subtract. That's just addition. For subtraction, I want to go the other way. So I'm going to take my 5 and I'm going to go backwards 8. Okay, for minus 8, I want to go to the left 8. So 1, 2, 3, 4, 5, 6, 7, 8. And where does that take me? Well, 5, 4, 3, 2, 1, 0. Might be worth putting my 0 on there. -1, -2, -3. So my answer for this one would be -3. For this one would be 13. The vertical layout method just says, that method we learned when we were in elementary school. And I'm going to add them straight down. 3 plus 5 is 8. 2 plus 4 is 6. And 1 plus 0 is 1. So when I add those two numbers, I get 168. For subtraction, we can do the same thing. It's a little bit different. Remember, when we have a bigger number on the bottom, we have to borrow 1 from the place before. Turn that into a 1 and that into a 13. And 13 minus 5, you have to kind of know what that is. That's 8. Again, I kind of have to do that same idea again. Borrow from the 1, make that an 11. So 11 minus 4, that's 7. So we get 78. So what do I do when there's too many negatives? Well, when there's too many negatives, I want to simplify it as much as I can. And the way that I do that is I look at those two negatives right next to each other become a positive. Okay? When I subtract a negative, it's just the same as adding a positive. All right? And you could look at that whether you looked at it on the number line idea. On the number line, you'd be looking at, starting at -5, and you want to subtract, so you want to go left. But then when you subtract a negative, it actually turns it into going the other way. So I'd want to end up going this way, 7. That would be the number line idea. Typically we don't show any of that. We just add or subtract these numbers. And when we can get away with it, just doing it by hand, that's obviously better. Not by hand, but just in our head. So what do we really get here? We get -5 plus 7. Another important idea is, what does this really mean? Or what is another way that I could write this? Obviously, what does this really mean? It means -5 plus 7. There's no great way to debunk that. But I can switch places with these. And we were always told growing up that that addition can switch around, and we were actually told subtraction couldn't. Well, the little secret is that subtraction can, because this is actually a subtraction problem. But you have to track that negative with the number that it's attached to. So I have -5 and +7. Okay, and the way I actually think about those is I just want to combine those. What happens when I push those two numbers together with addition and subtraction? So if I wanted to switch places with these, and I wanted to switch places, I'd get 7 minus 5. That's a nicer way to say it. I could also say, if I'd rather, I could say 7 plus a -5, but that's weird. Personally, I don't like doing that. I don't like saying 7 plus a -5. I would rather see it as 7 minus 5. And 7 minus 5, that one's pretty easy. It's just 2. Okay. The other way that I've seen that double negative turning into a positive done is, instead of making the 2 positives, I've seen people turn the 2 negatives into the horizontal part, and kind of this opening parentheses as the vertical part, and just turning it into a plus sign that way. And that, if that visual helps you, you can kind of see at the start of this problem that there's kind of a hidden plus sign here. And if you like that method, go with that method, and that can help you out. But what does that really mean? Again, it means that I have -15 and +13, and I'm just pushing those two numbers together. I could do the same trick, and I could say that it's 13 minus 15. But I just think I have a -15 and I have a +13. What happens when I push those together? I'm going to get a -2. And last but not least, I've got, again, a double negative turns into positive, 72 and 28. No real good way to do that. You can go vertical, but it's just you should just get that it equals 100. Okay. So these next couple, same idea really. I want to add these. Okay, these two I want to add because it's just a double negative. And again, I just kind of have to think, well, what does 14 and 35 get me? Well, 4 and 5 is 9. 3 and 1 is 4. So I get 49 for an answer. Same idea here. I've got the double negatives. I can turn those into positives. 74, so -74 and +39. -74 plus 39. Now, there's no great way to do that, and we're definitely going to see that on the next problem if you're looking ahead. Another way you can do this is if you do rewrite it the other way and say that it's 39 minus 74. My math teachers, when I was growing up, it was obviously a different time. They told me, you'd never have a calculator with you all the time. Well, turns out they were wrong. I mean, I have a calculator right here handy because I'm on a computer. But also, you have one just being, your cell phone works as a calculator. All of them do. So I can treat this as 39 minus 74, which is a lot easier to plug into a calculator than -74 plus 39. This one's pretty easy. This gets me -35. So I'm trying to give you multiple options on how you can accomplish these problems. And all I can hope is that it works out. At least one of them works out. Next one, I get that double negative again, so I'm undoing that. Undoing that double negative, I have -732 and +547. Maybe I rewrite that. 547 is positive, and I'll put my negative at the end, 732. Okay, and then if you had to do this by hand, and you were strictly told that you had to do it by hand, you still can. When you're subtracting numbers, or if you have opposite signs, that's another way that people say that. Like I've got a -732 and a +547. Either way, I'm just going to subtract them. Try to fit it in here. I'm going to subtract these, and so this is a way that we can get away doing it without a calculator. I'm going to run out of room if I keep the same size here. I'm going to steal one here, and I get 12. 12 minus 7 is 5. 2 minus 4, I can't do that. I mean, I can, but it's not going to help me. So 12 minus 4, that's a little bit easier. That's going to be 8. And then 6 minus 5 is going to be 1. Now, I get, when I subtract those, I get 185. The trick is, sorry, that 8's a little rough. But the trick is when we subtract, or when we add two things with different signs, because again, this is just plus a negative 732. I want to subtract them, and I did, and I want to keep the sign of the bigger one. 732 is the bigger one, so I'm going to keep that sign. That sign is negative, and so I get negative 185. Okay, that one might be a little tricky. I know I didn't talk about it in class, but at the same time, like it is an idea. It is something that if you had to do these problems without use of a calculator, it shows you that you could do that. Looking at the next page, some basic rules for multiplying and dividing. Let's take a look at some of those. So I have kind of something that one of my students taught me. I'm not even going to take credit for this. Something one of my students taught me when I started teaching. They said, I've always known some of the basic rules of multiplying and dividing when I had negative numbers, but I kind of took what this student taught me to heart. He said, well, here's how I think of it, and I just kind of went with it. So I'm just going to put some positives and negatives in here, and just make myself a little multiplication chart here. What I think of this top row, I think of this as a type of person. So I'm going to say person up here. So for a type of person, if it's a plus, that means it's a good person. So for a good person, and that's going to be my plus. And my minus, and I may have done this backwards in class, but either way, that's okay. The minus is a bad person. So the minus is a bad person. And on the vertical side here, on these columns here, I'm going to think about different things happening. So things or events. You might think of it as an event. And so a plus is going to be a good thing. Let's go with event. Let's say good event. And the minus will be a bad event. Okay. So I have people and I have events. Let's go with I don't know, some way to kind of generalize this. So if I'm looking at each one of these boxes here, these are where the work happens. In this one I have a positive times a positive. And this works for dividing too. Okay, positive times a positive. So in this case, it would be a good event happening to a good person. So I think of like maybe superheroes, maybe what can I get here? The Avengers win the war, So let's go with some endgame stuff here. So the Avengers win the war. That's a good thing. Those are good people. Those are good persons. And a good event. That's a good thing. So that's good. If the Avengers win, that's good. Okay. Then the next one would be a bad person in a good event. So we're going to think let's go with plus for the horizontal, and the vertical is a minus. So that's just where these two rows and columns intersect here. So a positive times or divided by a negative. And in this case, it's going to be, let's go with Thanos for the bad person. He's a bad guy. Okay? So Thanos, and the good event is wins the war. So Thanos wins the war. Well, that's bad. Okay, that's bad. And this one up here, I have my stick to my same idea here. So this will be a minus and a plus. And this would be the Avengers lose the war. It's a bad event. So it's the Avengers lose. So that's bad. Unless you're a diehard Thanos fan, I don't know. And then bad person, bad event. So that's going to be like a negative times a negative. And so negative times a negative, and bad person with bad. So Thanos loses the war because it's the bad event. Well, that's a good thing. If Thanos loses, that's good. So this shows you what the signs of your multiplication and division should be. Okay? Good things. Whenever we have a good in here, it's a positive. Whenever we have a bad, it's a negative. Okay? So that's just had a student teach me that, and that was funny. I'd never heard of that rendition of it before. So now we're moving on to multiplication and what multiplication really means. Okay? Multiplication by itself means repeated addition. Okay? And so if I have two numbers and I really want to multiply them, what does that mean I'm going to be doing? If I want to multiply 5 times 8, that means I want to really add 8 5 times, or I could add 5 8 times, either one. I'm going to stick to add 8 5 times. So I have 8 plus 8 plus 8 plus 8 plus 8. And when I get that done, 8 plus 8 plus 8 plus 8 plus 8, I can count by 8s if I want to. Sometimes that's a little bit hard. Or I can just add one step at a time. Okay? Either way, I should come up with 40. Okay, so I come up with 40 for that one. Whenever I have a negative, I'm not really going to focus on that. I can do two things. I can either keep that negative every single time, or just use my little chart up here. This is a negative times a positive, so negative times a positive is right here. I know that my answer is going to be negative. That's another way I could go at it. Or I can just think, I want to do that negative 7. I want to add it to itself 4 times. Plus negative 7. Oh, hold on. Let me just erase. If I hit the back arrow, it's probably going to undo more than I want. So plus negative 7. And so again, you can count by 7s. You can just add 7 together 4 times and then make it negative. Whatever works for you, but you should come up with negative 28. Okay. Go ahead and pause the video and try that next problem. So hopefully you got an answer there. I'm going to give you a kind of an idea of how I do something like this. I chose to add 15 9 times. I felt like it was better to write 9 15s than 15 9s, but it's totally up to you. I go ahead and combine these, like piece by piece. I find this to be a little bit easier. If I add up all these 15s, it doesn't seem like such a chore. Because 15 plus 15 is 30, and then that one just is stuck on the end there without a partner. And still we'd be adding, right? We'd be adding all these things together. Well, I know that 30 and 30 is 60. 30 and 30 is 60. I'm still stuck with that pesky 15 on the end. And then 60 and 60 is 120. And still stuck with that 15 on the end. But that's going to tell me that it's 135. So kind of I mean, it definitely takes a little bit more work, but it's, it's doable. Okay. Next, we have two methods for dividing. I consider there to be kind of a lot of methods to dividing, but the two that we're going to talk about, the first one is repeated subtraction. And the second one is going to be split into even groups. Got to spell right. There we go. So for repeated subtraction, all right, this might take a little bit of work, but just because I'm going to be subtracting 2 off of 16 a bunch of times. In fact, I'm gonna subtract until I get to 0. And this works when I know that they're divisible by each other. I know that I'm going to get an integer answer. If I end up getting a decimal answer, that's going to look a little bit different. But all I'm going to do is subtract 2 multiple times. And I'll talk about what I'm actually looking for as an answer, because if this works out, it would almost look like my answer would be the same thing every time. I'm going to run out of room. I'm going to put 6 back up here and go again. Subtract 2 gives me 4. Subtract 2 gives me 2. And subtract 2, yeah, I got 0. Okay, that's an important fact there. So now all I have to do is I have to count out the number of times I subtracted 2. And that's going to be my answer. So I see I've got 1, 2, 3, 4, 5, 6, 7, 8. So that's going to tell me that this is actually equal to 8. Okay. Now there's a bunch of different ways to do that same problem. I know plenty of people that are just as successful with division as just thinking of it as the opposite of multiplication. They think I need to multiply 2 by something to get 16, and 2 times what would give me 16, and I've found a lot more students are actually okay with that method, and that's okay. I'm just giving you another way that you can do it. Okay. The other way that we'll talk about, this split into even groups, it's kind of tough. I always look at this as kind of one of those tough things to really talk about, but I'm just going to start off by putting 18 dots. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17, 18. And now what I'm going to do is split them into even groups, and they're going to be groups of 3 because of this. So I'm going to take that 3 and I'm going to say I need groups of 3. So here's a group of 3, a group of 3 right below it. And it takes a little practice on knowing which ones to pick so that you kind of make life a little bit easier on yourself. Here's another group of 3 here. And then I've got one kind of goofy looking group of 3 right here. How many groups are there? 1, 2, 3, 4, 5, 6. So there's 6. So 18 divided by 3 would give me 6 as an answer. Okay. So that's just an idea. That's a way to divide. Obviously, like I said, there's plenty of people that might just know what 18 divided by 3 is, and that's okay. Obviously, a calculator is another way, but we're saying, oh no, my phone's dead. My phone's dead right now, so I couldn't use my phone. I could have used the calculator on the computer, but And then, like I said, there's the other way that people know just by saying, hey, 3 times what would give me 18? So they're kind of going at a backwards method, and that's okay. Like I said, I'm just giving you other tools in your mathematical toolbox. That being said, best of luck to you on the assignments, and hopefully we can get assignments 1 and 2 done by Wednesday. And other than that, go out there, be great, have a good time. We'll see you later.